Okay, so yesterday we went from this form to this form, right? That's what we did yesterday. Remember, you had to FOIL out the x minus p, and then you had to, right? And then you got that. Well, do you know that ax squared plus bx plus c is kind of useless? It doesn't tell us what the vertex is, which is, if you're going to do a parabola, you need the vertex, because it starts from that way and either goes down to, or it starts from that point and goes up to. So if you don't know the vertex, it's pretty hard to picture the graph. And if you just look at it as ax squared plus bx plus c, you can't just picture the graph. But we were doing it just to algebraically show you how to get there. The lesson today is we're going to be going from here to here. So we're going to learn how to complete the square. Now, why are we completing the square? Like, why do we need a perfect square? Do you see that in here is a perfect square? Okay, this is a perfect square. Now, today we're going to learn how to make perfect squares. But let's do some perfect squares to see some commonalities. So x plus 4 squared. Well, that's a perfect square, obviously, because it's the same thing. Well, that's the same thing as x plus 4 times x plus 4. And if we FOIL, that's x squared plus 4x plus 4x is 8x plus 16. Okay? Now, let's do x minus 5 squared. That would be x squared minus 5x is minus 10x. Minus 5 is plus 25. Now, here's where you're going to have to dig deep. What is similar about both of those perfect, like those answers? Do you see any similarities between the top one and the bottom one? Anything? Both have x squareds first. Yes? Yes? 25 and 16 are both perfect squares. Yeah? Nice. Yeah. If you square root x squared, you get x. If you square root 16, you get the 4. Same with the... Another one? Or just itchy head? Okay. Mess it with me. Okay. So I'm gonna show you one other thing that is very kind of necessary. I want you to look at this number and this number. They have a relationship, the same relationship these two have. So multiplying by 2, you might say is the first relationship, but that only happens once in a while. But there is a relationship between negative 10 and 25 and negative 8 and 16. Yeah? Okay. Right. Okay, that's awesome. If you take that middle number and divide by 2, then square it, you get that last number. Now that is huge, because that relationship is what we're going to be talking about today. Okay? And now look at the next, let's do x plus 7 squared. That would be x squared plus 7x is 14x plus 49. Okay? Now, look at it again. Does Tyson's rule fit there? Okay? And I bet you if we did 1,000 of them, that would fit. Now that is really, yeah, we'll call that Tyson's rule. Okay? Now, why do we need to know that? Well, what if I said, if I had x squared plus 20x. What would go here to make that a perfect square? 100. Okay? Now, do you see how knowing a little trick really makes these things easy? Now, what would the perfect square be? X plus 10 squared, right? Or x, you don't need that. See, you just made a perfect square. And then, now, does everybody understand? And this has got to be huge too. Does everybody understand that these are identical? They are the same thing. FOIL it out. You will get the top. Now, I can't even go on unless you're buying into this. Because today, we're going to be making perfect squares. And if we forget Tyson's rule, we can't make perfect squares. Now, why do we want to make perfect squares? Well, do you see this form? Always has a perfect square in it. Why do we want that form? It gives us the vertex. Okay? So, that's why we need to know this. That's why it helps us. So, we're going to go right to me showing you how to do this. So I have y equals x squared plus 10x plus... Now, here's what I do. I leave some space and then I put plus 16 out here. You'll see why in a second. Now remember, I'm getting to that form that has a perfect square in it. So we need to make a perfect square. So, let's make a perfect square right here. What would I put as the next number to make all of that a perfect square? Plus 25. Now, could you just go and add 25 to an equation and keep it the same? No, you can't. So, am I allowed to do that? What's plus 25 minus 25? Can I add 0 to an equation and not change it? Yep. Now, what a waste of time. You just added 0. Oh, yeah, okay, that's a great step. But you know what? I'm serving two masters here. One master is I need to make a perfect square. The other master is I can't change the equation. So how can I make a perfect square and not change the equation? Add a number and subtract the same number from it. Now that number has to be deliberate. And we did it by Tyson's rule of divide by 2 and square. You see that thing in the rectangle is a perfect square. Does everyone get that? What is that perfect square? X plus 5 squared. Now, here's something that I always want you to make sure. This is always the same sign. And we'll see why later. And this is always half of that number. Or like someone said, and it is also, so this has to be 0.5 of this, and this has to be the square root of that one. But they will always if you made a perfect square. And now, what's negative 25 plus 16? Negative 9. Look what we did. We made ax minus p squared plus q. So, now, what would the vertex be? Now, I want you to think. Y equals ax minus p squared plus q. What's p? What's the vertex? Minus 5. Does everyone see that? What? Ours says plus 5. What do you mean? Where'd you get a minus 5 from? Right, because this is supposed to be minus p. So that would have to be, to make this true, I would have to go x minus negative 5 squared. It's supposed to be minus p. That's the form it's got to be in. Plus q. So plus negative 9. So do you see the vertex would be negative 5, negative 9? Does that make sense? Okay, now we did some of those, last day, right? Would this graph be going up or down? Why? A is positive, right? So this is going up, and the stretch factor would be no stretch factor on it at all. So now we can draw a graph, because where's negative 5, negative 9? Okay, negative 5, negative 9 is down here, and then it's just a normal graph, right? So there's a purpose to completing the square, and that is to get it in a form that I can actually draw a picture from it. Okay? Now, let's do another one. So y equals, so I go x squared minus 9x, leave some room, and then go minus 20. Now, everybody do it in their head. What am I going to plus and minus? Okay, and don't say it out. I want to pick somebody. What are the numbers I'm going to add, subtract? Because I want a perfect square. I want to make a perfect square, and I don't want to change the equation. Okay, Scott, what would I do? No. What do I do? Negative 9. Divide by 2, and then square it. Remember the rules? Divide by 2, then square it. Negative 9 divided by 2 is 9 over 2. What's negative 9 over 2 times negative 9 over 2? Negative, no, we don't want decimals. 81 over 4. Okay? So if you need to do this on the side, this is 9 over 2 squared, right? Which equals 81 over 4. Now, do you notice what this sign will always be, this one here? What will this always be? Positive, because when you square something, it'll always be positive. And then minus 81 over 4. Now, we'll see if you guys are paying attention to what I said. What will this be right here? X minus 9 over 2 squared. What did I say is a relationship between these two? It's always a half of it, right? Make sure your negatives are always the same. Now, then I've got to do negative 81 over 4 minus 20. And you guys can put that in your calculator. Negative 81 over 4 minus 20, math, enter, enter. What do you get? 1/4. Negative 161 over 4. What's the vertex? No. 9 over 2, comma, negative 161 over 4, because it's supposed to be plus q. And is that a minimum or a maximum, do you think? Minimum? Maximum? What? It's a minimum. Why? Because this is going up. So it's going up. And by that I mean opening up, right? When I say going up, it's going up. Therefore, it is a minimum. Okay, so let's look at the steps above. It says step 1. I'm right here. Take half the numerical coefficient of the x term and square it. Add and subtract the squared number in step 1. This keeps the value the same. And then form a perfect square from the one you made, and then write it in factored form. Okay? Now, maybe you're going to do your steps a little bit more specific, but I'd like to know, like, if you can actually make steps that you can do, because these are the same every time. Okay? But what's the same every time? See, I showed you the sign. I showed you how to get your square, your perfect square, divide by 2 square. That's the same every time. Little things like that, that will make you better at the math. It's the technical stuff, okay? If any of you have ever had a good coach that you could say he was an awesome coach, I bet you he was very, very technical. He could tell you the littlest thing, how to change something. Those are good coaches, okay? Like, coaching can be all about, hey, good job, you guys, awesome, work hard out there. Everybody comes in and says, I need you to work harder out there. Okay, coach, we'll do that, work harder. I have no idea what to do harder, but I'll work harder, okay? But if a coach can pull you off and say, when you're skating, your arms are going side to side, they should be going front back, it's really messing with your momentum, work on that. Those are little things that as a player you're going, oh, cool, thanks. Okay? So they're not just saying, you need to skate harder, you need to put more effort in. You're like, holy crap, I'm putting all the effort I can, what does he want out of me, right? But if he says, oh, you're going to be so much faster if you just change this one thing. Okay? Well, that's kind of cool. You get to go out there and just work on that one thing, and then you find you get faster, right? So you'll know as you've probably had someone or some coach or something that has got it so technical. He knows all the little things so well that that's how they become good coaches. And you never see that on TV. But those coaches that are coaching in the NHL or, NBA or whatever, they know the little things really, really well. Not just how to be able to get a team motivated and get them all pumped up and get them out there on the court or on the ice or whatever, right? Hey, if you've ever taken golfing lessons or those golf pros have everything down to, your foot's a little bit off, your knees aren't bent just enough, you're tight in the shoulders, all these things, right? That's what, it's not like, yeah, I don't know, it's going weird. You're kind of slicing it out all the time. I don't really know why. It's probably wrong clubs. You need to get better clubs. You know what? If you spend twice as much on those clubs, it'll be way better, right? And then you spend twice as much. You're like, yeah, I think I'm way better. This is awesome. I shouldn't have had such cheap clubs. Okay, now we're going to actually change something. And now there's going to be the A value in the front. Okay, do you see there was only ones before? So these ones are a little different. Now, again, just humor me and write it down just like I do. Okay, y equals 3x squared minus 18x plus 20. Okay? You get that 20 out of there. I don't really care about it. So I'm just caring about those first two with x's in them. And then even to kind of force it even more, I'm just going to put a rectangle about those two. Now, do you see the number in front of the x squared? It's a 3. I need to take the 3 out. And I'm going to put it in front of brackets. But I'm going to take it out of those two terms. Now, I'm picking 3 because I want it to be 1x squared. But you have to do it to both of those. You have to take a 3 out. So you will get this. Y equals 3, bracket, x squared minus 6x. Leave some space, and then leave some space again and put plus 20. Oops, plus 20. Okay? Now, when I was a student and obviously teaching it, I've had to do like hundreds and hundreds of these. Okay? Because completing the square, you get really, really good at them the more you do. Okay? It is just a repetition skill that after a while you're going, oh, these are the same every time. You just do this, 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 then you're done. You pull that over there, divide that out, and you're good to go. Okay? Now, the reason why I've done that is because I need room to make a perfect square inside there. Now, what would be the number that comes after the negative 6x that will make a perfect square for me? Positive 9. Negative 3, or negative 6 divided by 2 is negative 3. Negative 3 times negative 3 is positive 9. And then I put minus 9. Okay? Now, see that -9? It's cramping my style. It's not supposed to be in there with the brackets. If I could get it out of there, then I'd have my nice perfect square in there. Okay? So I need to boot it out. But you just can't take -9 and put it out of the brackets. What you do is you take this number in front, you multiply it by here, and boot it out. So then what does it become? -27. And then cross it out. After I boot it out, I cross it out. Now, do you see how I have my nice little perfect square in brackets? Okay. Now don't forget about the 3. He's a person 2. What will be my perfect square? Let's see if you can get this one right. X minus 3. Now, did you check this? Is that the same, and is that a half? What will be outside the brackets? -7. What's the vertex? Remember, x minus p, so p is 3, -7. Okay? This is going up or down? Why? Because it's positive. And what is the stretch factor? Good. Vertical stretch of 3 about the x-axis, right? So once we get it into that form, it's pretty sweet. Because I can tell you everything about that graph right now. So completing the square, if you know all those little things, these are easy. The challenge you have to set up before you is, can you make the steps? Can you write yourself a steps with the example beside it that you could do any question? Okay? And you can check. Make sure the negative sign's here. Make sure this is a half. And I get this question all the time. Mr. What happened to the 9? What happened to the 9? Like it's just gone. Okay? And I said, but we made this on purpose because we knew it would make this. So this is this. Do you see that? This thing here, it's identical to this. Okay? You need to always know that x squared minus 6x plus 9 is the same thing as x minus 3 squared. Those are identical. No, not the 3 out front. I'm just talking about the x squared minus 6x plus 9. Okay? Those are the same thing. Okay? Don't, and it's like how do you know it makes a perfect square? I always get that one too. Because we made it a perfect square. We made it in the first place. And like I said, it's like $20 in your pocket every day. And the next day pulling it out going, awesome! I found 20 bucks. People would be like, but you put it there. No, I never. Yeah, you did. You do this every day. You always come to school bragging how you found 20 bucks in your pocket. You put it there all the time, okay? So you made the perfect square. Don't get all freaked out that it makes a perfect square. Because you made it, okay? Let's do another one. Now, why is example 4 any different? It's not in the right order. So, because we can do what we want to do, I'm just going to put it in the right order. And I'm going to do the, let's just get it in the right order. Now, remember, I care about these two. I want to take out the -2. And that will leave me with x squared minus 5x. Leave some room again and put plus 7. Now, why have I done this? Because I know where I'm going, okay? If you know where you're going sometimes, you can be a little bit proactive. Because if you put that bracket too close, then you're like scrunching all this stuff in here, and then you can't even read it. And then because you can't even read it, you make mistakes, and because you make mistakes, you get 0 on your quiz. So it all sucks. So then Let's just be proactive. Yes? Because I want to make a perfect square. And the 7 has nothing to do with my perfect square. Okay? If I left the 7 in there, then I'd have to do some perfect square stuff again. So it's like, just get it out of there. Okay? Now, what? Right? So it's going to be that. I guarantee it. What is that number going to be? 25 over 4. Very good. 5 over 2 squared is 25 over 4. Okay? What do I want to do next? Boot it out. So I actually used, see this? I got to get it out of here. It is cramping the perfect square style. Like, you know what? It just doesn't belong there. Don't want you hanging out here. So you can put in your calculator. What do you get? Positive 25 over 2. So I actually draw that I booted it out and then I cross it out, right? Because I got to be deliberate about, remember, if I keep doing the same thing every single time, you just get a memory about it. If it's muscle memory, whatever, right? Like I said, with the 7-iron, just do it over and over and over and over and over till you're like so sick of it. That probably means you're good at it. Okay? Now, what would be the perfect square? X minus 5 over 2 squared. Don't forget the squared. Did I forget it last time? No. Okay, don't forget the squared. And double check. Same sign. Is that half? Yep, yep. And then 25 over 2 plus 7? Plus 39 over 2. What would be the vertex? 5 over 2, 39 over 2 positive, because it's x minus p squared plus q. So whatever comes after the minus sign for the first one and after the plus sign for the second one. Would this be going up or down? This would be down, right? What's up? Because it's supposed to be y equals a x minus p squared plus q, right? So whatever p is, whatever's after the minus sign, that's what p is. Whatever's after the plus sign. You can see there's going to be a lot of confusion on this exam. And you mess up one little thing throughout the exam, you're going to do not well. Okay? So it's the little things that will kill you on this one. And people always say, you know, it's the little things that matter. It's what it's trying to say is, like I said before, you give me the fastest, most expensive car in the world, and just let me take out one $5 spark plug. That's it. That's all I want is one, and I will beat it in a race. Okay, I'll run. Okay, your most expensive. I just get to take out a $5 spark plug. That's it. I'll crawl. How about that? I'll crawl and I'll beat your sports car. Okay, so then you start to go, okay, it is the little things that matter. Okay, there's actually a good saying that, you know, if you think the little things don't matter, try sleeping in a tent with one mosquito buzzing around. Just one little mosquito. And there, you know, that high pitch, okay? So the little things sometimes matter when you're in a tent with a mosquito. Okay. We're just doing one more because I want to really reinforce this. Okay, so y equals 3x squared minus 12x minus 8. Do this, draw a rectangle. Y equals, what should I take out? 3, that would be bracket. Tell me what to write. X squared minus 4x. Leave some room, do a bracket, leave some room, put the minus 8. Okay, so see the redundancy. That's why I'm doing another one. Okay, what's wrong? 12 divided by 3. I'm taking the 3 out. Okay? You had me second guessing it too. I'm like 6. It might be. Okay. So it's plus minus this. 4, 4. Then, what am I going to do? I'm going to kick this out, because you do not belong here. What will it be? Negative 12. And then cross it out, because that was obviously the point. So this would be y equals 3 something squared. X minus 2 squared. Minus 20. Okay, on your own, write down the vertex. I'm not going to tell you. Write down a x minus p squared plus q underneath, and make sure what would come after. That should be a minus sign, so then that would be, see if you're getting that right. Okay, Jason, what would your vertex be? Okay, very good. Does that make sense? Now, we're going to actually add one more thing to this. I want the x-intercepts. Now, remember, x-intercepts are when we make y equals 0. So, let's do that. 0 would equal, and we're going to use our answer because it actually, this really helps us out doing these. They're way, way more work if it's in the quadratic way. Because then you've got to find out what plus what equals this, what times what equals this. And if they're not nice numbers, life is horrible, okay? So, these aren't nice numbers. So, first thing we're going to do is add 20. 20 equals 3x minus 2 squared. Then I will divide by 3, right? So that's 1. And then I will square root, right? And make sure I put a plus minus here. So then I have plus minus root 20 over 3 equals x minus 2. So my final answer is plus or minus root 20 over 3 plus 2 equals 0. Okay? So it's positive root 20 over 3 plus 2 and negative root 20 over 3. I don't know if you would come up with those guessing what two numbers add to give you this and multiply to give you this, right? So this, and that's not a lot of math. Like I didn't go for that long. This is a great way to be able to solve and find your two x-intercepts. So what is positive root 20 over 3 plus 2? Just because I want to see what would this look like, this thing. What do you got? So 4.58 is one x-intercept. And what's the other one? 0.58. Make sure root 20 over 3 stays in brackets, right? Now, why does this help me? Okay, well, let's draw a graph, right? Again, it doesn't have to be perfect, but 2, negative 20 is like way down here, right? 2, negative 20. Now, is this going up or down? Yeah, it should be going up because, and it's going through negative 0.58 and 4.58. Right there and there. Okay? Oops. No, that's not right. What am I doing? Negative 4.58 would be over here. And say negative 20 would be over here. Or negative 0.58 and 4.58. Okay? That's what my graph would look like. I can do that all from the perfect square form. ax squared plus bx plus c, I can't do any of this. I can do a, that's the stretch factor, but Okay, so there's 11 questions. You're doing 2 to 5. All of them are just perfect square, and not A, C, E, G, all of them. Because I just want you doing this concept. That's it. I don't want you moving off of it. So, and there's lots of time for everybody to finish in class or ask for help or... So number 2 just gets you going on finding perfect squares. 3 is just nice, easy ones. Then 5 gets to the ones that have numbers in the front, right? Whatever.